This is part 2 of the three-dimensional graph using draw, and we're going to continue with the following document where I have already copied the specifications for the graph. I'm going to start with a 3D here, say OK, and give some space in here, and return my cursor to here. Then we go for a parametric. So it's a parametric plot. We did the implicit already. Expression to calculate the value of x. Actually, I'm going to make them up. It's going to be 3 times sine of t. The value of y will be, let's say, 4 times cosine of t. And z is 2.5 times t. And the value of t goes from 0 to 20. So I got 0 to 20, and we say OK. Next, title, example 3D parametric. And then we go for the axis, x in meters, y in meters, z in meters, with the ranges from -3 to 3, -3. This can be changed after that if it doesn't look quite what you expect. Okay. Actually, the z range should be 0 to 50, so we go here. I'm going to have to add some spaces and then take them out. And so it's from 0 to 50. And we click here, and then the grid. Okay, that's what this allows. The line color could be changed. Let's do it right now, and then we'll change the line color. And so it's producing a broken line. I need a larger x and y grid. Let's try -5 to 5, -5 to 5. That's better. So it's kind of a spiral curve that we have with these parametric equations. Now I'm going to delete some of the spaces here. I say you can change the color of the line color, so you could, let's do it right at the top and go for line color, and let's change to something red. Shift enter, and there it is. And so that's the case of a parametric, three-dimensional. Parametric is basically a line. There are ways to do surface when the parameters for x, y, and z are two-dimensional, but this is only allows one parameter, so we're going to just do graphics like that. And so that's the example for a sorry, we have the list here, right here. And then the next one is contours. I'm going to copy these, create a new file, close these, insert the text cell, Control V, and then we start with our 3D. Okay. I'm going to give it all spaces here. 3D. And now we have contours. And so for contours, it's basically an expression. And let's do z equals sine of x times cosine of y as indicated in there, with x between -5 and 5, y between -5 and 5. And so we give a diagram title and say contours. We can have axis X label, let's say, let's just call X, Y, and Z, and not worry about the ranges. And then we go to contour. And this is contour, no contour lines on the surface, contour lines on the bottom, contour lines on the surface and bottom. We go for that one, in both. And then we're going to add this spec. And I'm going to add it here at the end. It's going to put a comma, enter, control V. Shift enter. And this is what we get. So you can see there the contours are in the surface and the contours are at the bottom. Now, I think that the positioning of that enhanced command is important. And let's see what happens if we put it before the graph is defined. So we're going to take this out, Control X, delete that comma, enter, Control V, Control. There is a oh, I forgot to put a comma here. So now we get the enhanced graphic, and you can see the contours more clearly. And remember, if you do a right click, and they'll pop out interactively. Bring the graph in. You can change the orientation. You can see the contours better, and so on. And so that's how we are going to present this wxMaxima use draw. We present the two-dimensional and three-dimensional. This is the second part of the two-dimensional graph, and with that we end this part of the wxMaxima presentations.